Alright guys, how's it going? So we're gonna continue with our little application, and now we're gonna write our three functions, which are push element, pop element, and print all of the elements of our stack. Of course, they are not gonna be difficult, but anyways, it might benefit you greatly. It's gonna sharp your programming skills, problem solving skills, and analytical skills, and it's gonna improve your mental health in general, at least in my opinion, because programming is always good for your mental health, I believe. Alright, but anyways, let's write our little functions. So we're gonna say void push element is struct st int element. We assume that all of our elements are integers, as I already mentioned. Alright, for the sake of simplicity, just not to overcomplicate this example. Alright, so first of all, before we push a new element on the top of the stack, we should check if our stack is full, because otherwise, and just to remind you guys, we are now working with arrays, and for those of you who is not familiar with the concept of C-style arrays in the C programming language, I just want to say that it's a special kind of an array which is not capable of keeping track of the size of its elements. I believe it's a little bit restricted and limited, I would say, data structure. But anyways, be that as it may, that it might be a little bit limited in its usage, still it is very powerful and widely used in the C programming world. Alright, and the system programming as well in general. Alright, but the problem is with the main problem, I'm getting off the track, sorry about that. So getting back to the track and talking about our algorithms, I would say that our arrays in the C programming language, they don't know their size, and that's why you always should be able to specify the size of the array beforehand. Alright, otherwise you won't be able to push a new element on the top of the stack. In other words, you won't be able to push a new element into your array if it's already full, right? Because the C programming language, the compiler, right, of C works as follows. First of all, it checks if the size of the array is, if it's full, right? If it is, then it makes copy. It allocates the memory, additional memory. And it's gonna copy the first part of the array, and next you'll be able to put a new element into your array, and this process might be very expensive in terms of time and efficiency. And memory, of course, and and there are other limitations, I would say, which I'm not gonna talk about in this video, because it's not what this video is about. But anyways, the C-style arrays are a little bit limited in their capacity, and in the C programming, the C++ programming language, for example, there is another type of an array which is called a vector, which acts similarly, in my opinion, like lists in Python, because they are much more flexible, much more powerful, yeah. But anyways, before pushing a new element onto the stack, we should be able to check if our stack is already full or not. So we're gonna say check. Let's check if the stack is already full. Alright, if, and above here we already specified the function which does just that. Alright, it checks if our stack is empty. If it's empty, and we're gonna pass struct string. Alright, then we're gonna say so what are we gonna say? We're gonna say stack not empty. Sorry about that, stupid me. We should check if the stack is full. Of course, it's full. The stack is full. All right. Printing a line. We're just gonna return. Okay. Sorry guys, we should have passed s over here. All right. So we checked if the stack is already full. So if it's not, we are just carrying on, right? So if it's not full, we first of all we're gonna increase the index of the last element, the array, by 1. So let's say as top plus plus, just increasing it by 1 makes we should assign a new element which is going to be passed in as an argument to the function. To the array, to the index of the array pointed at by top, I believe. Yeah. So we're just gonna say yes top. We're just gonna say as stack top, as top, like that. Right, it's gonna be equal to the element which is gonna be passed in here, okay, as an argument to this function. All right, and then yeah, we should probably include it in the else block as well. All right, I'm just gonna say this. Alright, and in the end we should be able to increment the number of the elements of the stack, I believe. And here we didn't specify the number of the elements, we didn't initialize it, so let's initialize it up here. In the beginning it's gonna be 0. It's gonna be just the number of the elements of our array, and we're gonna just we're gonna increase it by 1, count plus plus, just like that. Okay, and I think that's it. Next, we should be able to pop element from our data structure. Alright, so first of all we should check if the stack is already empty. In this case we won't be able to pop anything because it's empty, right? So we're gonna say if is empty, yes, and we're gonna say here we should use the printf function, which is a built-in function in C. We're gonna say the stack is empty, right? And we're gonna print a new line, and we're gonna return. Alright. Otherwise, so what are we gonna do in this case? So of course we should be able to return the current element, which is being popped out, I believe. So we're gonna say print the top element is some D. D is for decimal, I believe, since we're using integers in our application. So we're gonna say S no, we're gonna say stack S top, I believe. Yep, and next, what are we gonna do next? Next we're gonna decrement the number of, not the number, we're gonna decrement the index, the top, right, the top by 1. So this way we should be able to remove this top element from our array, from our stack, right? I'm just gonna say top stop minus minus, and that's pretty much it. And in the end we should say we should decrement the number number elements of the stack by 1, and here we should increase by 1 as well. So we're gonna say count minus minus. Alright, so the last function we should implement is alright, the last function we should be able to implement in our little application is printing our stack, printing all of the elements of our stack onto the screen. Alright, so it's quite a bit of code, right, guys? Quite a bit of code, really. Not bad at all. So we're gonna say void print stack struct string. So how are we gonna print all of the elements or stack onto the screen? So it's gonna be pretty simple. We should iterate through our array and print the values of each element on each iteration, I believe. Okay, so we're gonna use for loop here, I believe. We're gonna say for die equal to 0 as long as I less than count, which is the number of elements or a stack. Alright, I plus plus, and we should be able to print each element on every iteration. Okay, we're gonna say print f. Here we should have used printf here as well, of course. Sorry about that, guys. So we're gonna say, so what we're gonna say here, I think that we're gonna say outside of this for loop, we're gonna print this date and this expression, the string, I would say. The stack is alright here. Yeah. Just I'm gonna say send d just in order to use integers, alright? The integer array. I'm gonna say s stack I believe, yeah, we're just gonna say this stack I. Okay, and I think that should do it, if I'm not mistaken. And after we're done, we should print a new line, I believe. Alright, new line. Okay, and I think that now we're ready to check, to test our little algorithm. So alright, struct, yep. So first of all, we should be able to create a new stack. So in the C++ or in the C programming language, C / C++ programming languages, because they are they go hand in hand, in my opinion. They're pretty similar, but anyways, in order to create a new stack on the heap, and heap, by the way, for those of you guys who don't know, is, heap is part of dynamic memory in our computer, in your RAM, which is available during runtime rather than during compile time. Okay, and I think that it's a whole different topic, which I might discuss in future videos, I believe, if I have time, of course. Yeah, but for you guys, I will do my best in order to explain any programming concepts in simple terms, as best as possible, at the best of my capabilities. Yeah, I promise you guys. Alright, but anyways, in order to create a new stack, we should dynamically allocate memory on the heap. We're gonna say stack, we're gonna say struct, just call it struct string s right? Yep, equals malloc, and malloc is part of the C programming language, which deals with dynamic memory allocation. It creates block, I would say block in memory. In dynamic memory, allocates dynamically memory on the heap. The size of the structure, in our case, right? Like this. And after allocating this memory, this malloc is going to give us a void pointer. And if we want to be able to use this block of memory, right, we should be able to dereference it using pointers. And in order to access the values which are going to be put into this memory location, we should be able to cast the type of void pointer, which is going to give you which gives you the malloc function into this type of struct. All right, it's a little bit hard to explain, guys, since you know, my native language is not the English language, as you already figured out, I believe, but I'll do my best to explain you all of the concepts, the programming concept, because I'm a professional programmer, and I think that just by explaining these little algorithms, not only will you benefit, hopefully, but also I will be able to a little bit improve my spoken English. All right, so just to remind you, all right, just in case. Okay, don't judge me too seriously, all right, for my English, guys. All right, but anyways, we're gonna create an empty stack. Okay, we're gonna say create empty stack. We're gonna pass this pointer as an argument. Okay, so, and now we can push a couple of elements onto our stack. Push s. Let's push a couple of elements for our stack, just for the testing purposes, right? Push a couple of more. 25. Push s35. Push, and yeah, I think that should be enough. I think that now we can print the elements for our stack onto the screen. I'm gonna say print stack s, and yeah, we are ready to test our little algorithm. All right, so we're gonna say gcc stack c. All right, guys, seems like we're having some issue down here, and I think that I just misspelled the name of the function. Yeah, we should have said printf. All right, so let's recompile. All right, empty stack, create empty stack. Okay, guys. All right, guys, seems like I misspelled the name of this function. Sorry about that, guys. So let's try it one more time. Hopefully it works this time. All right, seems like it's worked. So let's run our program. All right, the stack is full. Yeah, that's correct, because 1, 2, 3, 4, 5. So alright, guys, let's push some elements into our stack. Push onto the stack. Alright, push element, let's say it's gonna be 50. Let's push a couple more, 70, push 90, for instance. For some reason I can't type today properly, sorry about that guys. 100. Now let's print our stack. Okay, so right guys, let's check it out. Alright, let's say GCC stack C, right, our elements 50, 70, 90, 100. 100 is was the last element to be pushed onto the stack. Alright, so let's try to remove the pop, the last element, right, from the stack. So let's check it out. GCC. The popped element is 100, right? Let's see, we're gonna have 50, 70, 90. So let's consider the case where our stack is full. Alright, now let's push a couple more elements. So here our capacity is 5 elements of the stack. Okay, so let's pretend that we wanna add the 6th element to our stack. So let's check if we can do that. Alright, the stack is full, right? And this last element we can add it onto the stack because our stack is full. Okay, seems like our little algorithm is working, and let's check. Let's check if our pop function works as well. So we pop, gonna pop it a couple of times. Pop, pop. So let's check it out. Alright, so let's pop a couple more until our stack is empty, right? Now let's pop one more time. So pop. Alright, so let's add some comments. And stack, right? So let's check it out. So the stack is empty. Alright, yep. Seems like our little algorithm is working correctly without any mistakes. So yeah, I think that should do it. So alright guys, and I think that we can stop here, and next time I believe that we're gonna implement the same data structure, maybe using a different programming language such as Python, just to make things a little bit much more various, I would say, a little bit more various and a little bit more interesting, because I think that you know, not everybody in the modern world of programming likes to use C++ or C programming languages anymore. Maybe I might be mistaken, of course, but I believe that young people, especially they, as far as I know, at least, they tend to use JavaScript and Python throughout their careers on daily basis, because those are the top technologies in the world, I believe. But be that as it may, that those languages, those aforementioned languages such as Python, are at the top, of course. Still, one shouldn't forget, I shouldn't underestimate the fact. I should say that these older languages such as C and C++, they are the foundation of everything in programming, I believe. And I strongly believe as well that every respected developer, or programmer, developer, software engineer, should to some extent be familiar at least with these amazing programming languages, because many operating systems such as Linux based and even Windows based, as far as I know, they use to some extent C and C++ programming languages in these operating systems. Alright, but anyways, guys, I hope you enjoyed this video, and I wish you all the best. I really appreciate all of your time, your precious time, and I believe that somehow you will be able to benefit from watching this little series. And guys, that's it, and I'll see you next time, and hope you're doing well, and take care. Bye bye.